So let's talk real quick about number 4. Okay, number 4 was one of the ones that I asked you to do for homework, and most of you got this right. Most of you were successful on this one. Just really quickly, most of you started here at 0 on the x-axis, on the x values, and you knew that the square root of 0 was 0. And then most of you put a 1 here and knew that the square root of 1 was 1. And then some of you did other numbers, but most of you did 4. Why in the world would you choose a 4 right there? Because you know the square root of it. So you're being lazy. Now, I know that word normally has a very negative connotation, right? Being lazy. But if you think about it in math, almost every mathematician will tell you that they're lazy. And by lazy, they mean they want to find the quickest and easiest way to do something. Guys, where do you think all the formulas came from? Mathematicians tired of doing work and work and work and work, and they started to see a pattern that worked every time, and they developed formulas. If that makes them lazy, then they're going to be okay with that. Be okay with you calling them lazy. Okay? So if I call you lazy, first of all, you're going to know if I'm meaning positive or negative, because most of the time I won't ever say a negative. Okay? Unless I want to kick you at the same time, but that's illegal, so I'm not going to do that. I'm also not allowed to hit. You're right, okay.
Unless it's with hats.
Oh, that's true. Okay. So, if I put the 4 in here, I know I'm going to get a whole number answer out of there, right? I know I'm going to get a 2. So what number would I choose next using that same kind of logic? 9, because I know I get a 3 out. And then 16, because I know I get a 4 out. Oh, I didn't put it in the middle, sorry. I just have to get over that. 25 and 5. Okay? So what about negative 1? All these numbers down here, we said what number times itself gives me my y value, right? 2 times 2 is 4, so that's why I said the square root of 4 is 2. What number times itself gives me that number? So what number times itself gives me a negative 1? Wait, you're telling me there's no numbers that multiply by itself that give you a negative 1?
No.
Okay, and I have to tell you that there's no numbers that you know yet. Dun dun dun. It's called foreshadowing. Okay? I'm foreshadowing an event to come. Okay? You don't know any numbers yet. So it doesn't matter what I put up here. Negative 4, negative 9, negative 16. If we put it in a calculator, it would say error. Okay? Now, have we talked about using the calculator at all in here yet? Is it because I'm a mean and evil person?
Yes.
No, it is not. Okay? I have not gotten the calculators out yet because I want you to be more comfortable with numbers. Okay? That's really important to me. I can't tell you how many times I'm walking around during a test and I pass somebody that's just entered 3 times 4 into their calculator. They know that the answer is 12, but they don't trust themselves in a high-stakes situation like a test to know 3 times 4. I want you to be more comfortable with numbers. Okay? So it's going to be a couple days before we get the calculators out. I promise when we get them out, you can use them, even to do 3 times 4. But I really want you to be more comfortable with the numbers. That's why I haven't gotten calculators out for you so far yet. Okay? It's not because I'm trying to be mean. And I haven't made you do stuff that's hard without a calculator. Okay? So now when I plot these, I can't plot any of these top ones because they all have an error. And when I plot these, it looks like this. Can I connect them? Yes or no? Yes? Why? Can I find the square root of 3? Can I find the square root of 7? Can I find the square root of 8.5? So all the points in between the points that I have listed really exist. I just don't have them graphed, don't they? Okay, so that is continuous. So I'm going to tell myself that over here. What did you decide about number 3? Is 3 continuous? X to the 3rd? Yes. Did you write continuous right here on the side? Would you please do that? As soon as you do that, we'll go back to number 4. Domain of number 4. How far to the left does it go? It goes to 0, right? How far to the right does it go? All the way. Okay? So how do we write that?
X is greater than or equal to 0.
Why did you say greater than or equal to 0 and not just greater than 0?
Because it can be 0.
Because it can be 0. Very good. Okay? And how do I write it the other way?
Bracket 0, comma, infinity.
Excellent. Bracket 0, comma, infinity. Parentheses. Because 0 is included. That's why I have a bracket right there. Okay? What about the range?
Y is greater than or equal to 0.
Very good. And the other way?
Bracket 0, comma, outside of 80.
Excellent. What's it called?
Infinity.
Sorry, I wasn't talking about this thing over here.
Change the name of it now.
What is this parent function called? How do you know that? How do you know it's called square root? How do you read this? Square root of x, right? Okay, so here's a question first because I hear some people saying square root and some people saying radical. Okay? So, you know that stuff I've got over there? Use it sometimes when you cry, sometimes you use it to blow your nose. You know, what is that? Kleenex. Sure. Oh, wait, Kleenex or tissues? Which one?
Yes. Same thing.
Yes, right? Kleenex is the brand name. Tissue is what they actually are, right? This symbol right here, that symbol is actually called a radical. But we use it most often to take the square root. Notice that there's a radical in number 5 as well, right? Is that a square root? No, because of that little baby 3 right there. We'll talk about what that's called in just a second. But the symbol is called a radical. The action we're taking with it is called a square root. So most of the time we call this a square root function. But I'm glad that you already know this name, this word, because vocabulary is important. Okay? Sometimes they are called radical functions. So keep that in mind, please. So now to number 5. Number 5 was also a homework problem, and I think you didn't do quite well on number 5 as you had hoped or as I would have hoped. Fair enough? Okay? So where did you start? 0 in the middle. Is that the middle? 0 in the middle. What is that? It's a square root with a cube, so what do we call that? Cube root. If a square root is what times itself gives me that number, how do we figure out a cube root?
That times itself.
That times itself times itself. So 3 things, right? So what times itself gives me 0? 0. So can I choose 1 as my x? What times itself equals 1? 1. Okay. 2? Do we know what times itself is 2? I don't. What's the next one that you know? 8? Where in the world did you get 8? Oh, 2 times 2 times 2. So guess what the cube root of 8 is? 2. So what do you think we might choose next? 27? What? What times itself is 27? 3. 64, 125. So what do we want to go up here? -1, -8, -27, -64, -125, right? And we already know those are all errors because it's going to be the same as up here, right?
No.
Second day of class and you're already arguing with me? Good for you. Defend yourself. Do it. Tell me why. What times itself? Times itself equals negative 1.
Times the negative is a positive. Times the negative is a negative.
Yeah, negative 1 times negative 1 is what? Positive 1 times negative 1 is what?
Negative 1.
Can you take the cube root of a negative number?
Yes.
Yes, negative 1. So what's the cube root of negative 8? Negative 2, negative 3, negative 4, and negative 5. Now we got to graph those. I forgot to mention something about number 3 that I saw, so I'm going to mention it now because it's kind of in the same situation as here. But I don't really want to draw it because I don't want you to draw it. So I'll draw it with pencil and then erase it. How about that? Although with pencil you're not going to be able to see it very well. So we'll just get over that, okay? This is what I saw people do.
Miss Kingston,
Yes, ma'am.
do you have Parker Jones?
Yes, I do.
Can you send him to the office, please?
Yes, I will. Parker,
Thank you.
Parker, you need to go to the office. Okay, no problem. I'm not leaving. You're leaving. Okay. So what did I do? Can you see that at all?
You made straight lines instead of curves.
Why would I have to make curved lines? Why is that a big deal? Because. That's exactly right. Because. Is this a linear function? No. Linear and only one other function that we draw, that we work with in Algebra 2 are straight lines. The rest of these need to be curvish. Okay? So you need to really try to make sure that these look curvish. Oh, dang, I forgot to ask you a question. What was it? Yeah, are we allowed to connect them?
Yeah. Oh, yeah.
Because they're continuous. Okay? What's the domain? How far left does it go? How far right does it go? All real numbers. What about the range? Same thing? All real numbers? Because it's how far down and how far up? Now, how would you talk to a friend of yours that said, when you said, what's the domain? They said negative 125 to positive 125. Do they understand a general idea about domain?
Yes.
Yes, that it's the x's, right? What don't they understand?
That it continues on.
That it continues on. Okay? So, would you be able to explain that to someone who was confused about it? Good. Most people don't get confused on the domain on this. They get confused on the range because it looks like it stops somewhere here and here. Right? It is going to keep going, not really dramatically, but it does keep going, doesn't it? Okay? What are special things? What's it called? Cube root. So no matter what we get finished in class today, what I need you to have done before you get back here tomorrow is 7, 8, and 9. Okay? We're going to go through 6 and we'll get started on 7. I don't know if we'll finish or not. It depends on the value of our discussion. Okay? But I need you to get 7, 8, and 9 done before you get back to class tomorrow. Fair enough? Okay? Oh, which brings me to another point I forgot to mention yesterday. Tutorials. I'm in here every morning from 7:45 to 8 o'clock. I'm not here Thursday morning because we start band at 7:45 on Thursday morning. Okay? If you need help on Thursday morning, you can talk to Mrs. Patton. You can talk to Mrs. Matos. Either one of them will be happy to help you on Thursday mornings. Okay? But I'm here every other morning, even Fridays when there's no tutorial scheduled. I'm in here. Okay? So just to make it clear, I want you to tell me if this statement is true or false. Only dumb people come to tutorials. False. That's a capital false. Like every letter is capital with 3 exclamation points. Okay? Who comes to tutorials?
People that care about
People that care about the class, people that have questions, people that need help. Okay? I had a student last year who came in here every day first semester and read a book. I don't know if you guys know this or not, but we don't usually read books in math. Right? That's mostly English. Okay? But it was too loud for her in the cafeteria, and she wanted a quiet place to read. She knew that even if there were people in here that were needing help, we usually stay kind of quiet because that lets people think better. Okay? I had people meet each other in here for tutorials. They didn't want to talk to me. I mean, they would if they needed help, but they met with the partner, with their friend, and worked on their stuff and then left. And some days they never even talked to me. I'm okay with that, unless they're hateful. Okay? But this is a place for you to come to practice. Okay? Fair enough? Okay. So what?
And watching reports.
Yes. Number 6. Where do you want to start?
0.
0 in the middle. Is this the middle? Is this the middle? I think that's the middle. All right. 1 divided by 0. Wait, what? What's 1 divided by 0?
1. Because anything divided by nothing is itself.
You're saying,
Undefined.
I'm saying take something and put it into 0 groups. Just by its value, it's already in 1 group, right? Can you put it in 0 groups? No, it's undefined. Undefined. Guys, there's only one person that I know that can divide by 0, and Chuck Norris is not in this class. Okay? So if he was here, we'd have a different story, but he's not here. I don't think he's ever even come to Clyde. I mean, I don't know. Maybe he does. I don't want to judge him. Okay? 0 is undefined. What should I choose next? 1. What's 1 divided by 1?
1.
Oh, you guys are so smart.
Everything's 1.
Everything's 1?
I think so.
So if I chose 2, what's 1 divided by 2?
0.5.
Oh, you guys are so chicken. It's 1/2. Guys, here's what I want you to know. This year, you're going to get more comfortable with fractions. Okay? Fractions are our friends. They are. They're not the friends that you go hang out with on the weekends. They're the friends you kind of just have to put up with having in your life. Do not say any names, because that's not even nice. But I know you guys are all thinking of who is one of those friends in your life. Don't say it out loud. Don't nudge each other. That's not even nice. Okay? Oh, don't even say that. That's worse.
What did you say?
That's all my friends.
Oh.
So,
Sad.
let me tell you this. Cube root, you hadn't really ever seen before, but it's a whole lot like square root, which you had. Cubed, you hadn't seen before, but it's a whole lot like squared, which you had. You'd seen linear before. This is the first one you haven't seen yet. Okay? I don't expect you to know this. What's my goal for the day?
To identify the parent function.
Did I say I want you to have this whole table memorized and the graph memorized and every domain and range and special things memorized? No, I want you to be able to identify a parent function. If I show you the graph, can you have a general idea of which parent function it is? That's what I need you to be able to do. So number 1, when we go through number 6, don't panic. Number 2, when we go through number 6, for a while, I need you to trust me that I know what I'm doing. Fair enough? Okay. So, the next number that I want to choose is 3. 1/3. And then I want to stop for a minute. And I want to graph what I have so far. I can't put anything at 0. 1, 1. 2, 1/2. 3, 1/3. So I want us to think for a second, what would it look like at 4 and at 5?
It's very close.
It's getting closer, it's getting closer, right? Then I want to jump up here and say, what if it's -1? I know I haven't finished with the positive numbers yet. Please just trust me for a minute, okay? What if x is -1? What's y? -1. So -1, -1. What if x is -2? -2, -1/2. Okay, -1/2. What if x is -3? -1/3. So we're here. And think with me for just a second, what would it be like if it was 4 and 5? Closer and closer to that axis, right? Is there any number that I could put in that will give me a 0? 1 over any number, will that give me a 0? No. So, I'm never going to get up to the 0 or down to the 0, am I? Okay? Now, if we left it like this, do you think you have a good idea of what this graph looks like? Yes is an appropriate answer because you've never seen it before, right? And we've chosen logical numbers just like we have on the other ones. But I know where we're going. So trust me for just a second. And let's choose 1/2 as x. Now I need you to remember 1 divided by 1/2. Do we ever divide by fractions? No, we always do what? Multiply by their reciprocals. So this gives me 2 over 2. What is 2 divided by 2? 1. So that's just a 1. So I have 1 times 2 over 1. What is that? 2. So when x is 1/2, y is 2. When x is 1/2, y is 2. Huh. What about if I chose 1/5? It would be 5, wouldn't it? When x is 1/5, y would be 1, 2, 3, 4, 5. Whoa. So what if I chose negative 1/2 and negative 1/5? I would get negative 2 and negative 5. Good. So negative 1/2 is negative 2 and negative 5. Does that look different than you thought it might? When I didn't have these two here before, it just kind of looked like it would go zhunk and zhunk, right? Am I allowed to connect these? Is this function continuous? I don't have the 0, right? I don't. It's almost like I have 2 different ones, right? I don't have the 0. But, okay, think about this. If I just had this side, is this side continuous? So can I connect these with each other? Okay. So carefully, not crossing either one of the axes. And wait, if I just had this side, would this side be continuous? Yes, so I can connect those with each other. What I cannot do is connect them with each other, because that would mean crossing the 0. And can I cross the 0? No. Okay? So over here, I'm very purposely not writing continuous. Wait, did I write it right here? I should have. Okay? This is not a continuous function because it has a hole in it, basically. Well, if there's another word for it, I'll teach it to you in just a second. Okay? What's the domain of this function? What x? Sometimes I ask you, what is x allowed to be? This time I'm going to ask you, what is x not allowed to be? It's not allowed to be 0, right? Is it allowed to be anything else? Anything? Any number but 0, right? So here's one way to write that. All real numbers, and x is not 0. It's okay. Finish this one up. Number 6. Have a good day.